નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Standard 9th, Subject Science, Chapter 8, Motion. Dear students, today we will discuss graphical representation of motion. In this graphical representation are of two types. Distance time graph. Second one, velocity time graph. In distance time graph, on the y-axis you have to take distance in meter. So distance you have to take, and x-axis you have to take time. Okay, distance in meter, and the time is second. Okay. Now in the velocity time graph you have to take, on the y-axis, velocity you have to take, and on the x-axis, time you have to take. Okay. So these are the things you have to keep in the mind. Okay, students. Dear students, first of all, we will discuss distance time graph. Okay, in distance time graphs and their types. See, first of all, here the object is already moved up to, we will take the object moved up to 30 meter here. Okay, see, the object moved up to the 30 meter. Already it is moved up to 30 meter. So, and after 10 seconds also it is 30 meter only. And after 20 seconds also it moved up to 30 meter. And even after 30 seconds also it is 30 meter. Even after 40 seconds also it is 30 meter. It moves, so it will see, it will go for making the line. It is a, so if you go for this line, okay, if you are joining these points, so it becomes a straight line here. See, it becomes a straight line. Okay, so like this, you will get the straight line. So after drawing this straight line, you will get. Okay, like this. Clear now? So straight line, you got it. So it means what? After 10 seconds also it is 30 meter only. After 20 seconds also it is 30 meter only. Even after 30 seconds also it is 30 meter. It means it is not moved. It is at rest only. It is at rest. Okay. The object is at rest. The object is at rest. See, line parallel to the x-axis. See, this line is parallel to the x-axis. This or time axis. See, line parallel to the x-axis or time axis. Then such a graph is now, the object is at rest. Object is at rest. Okay. Now we will see the second one. In second graph, we will see that, okay, the object start at 0. Okay, from 0 is here. After 10 seconds, it moved 10 meter. Okay, up to 10 meter. Okay, and after 20 seconds, it moved up to 20 meter. And after 30 seconds, it moved up to 30 meter. 30 seconds. After the 30 meter. Okay. Now, after 40 seconds, also it moved up to, see, every 10 seconds, 10 meter, it moved. So, object started with 0, and after 10 seconds, 10 meter, next 10 seconds, next 10 meter, so like this. So, if you join these points, see, if you join these points, you got a now, what you got? The straight line you got. So what do you got? Straight line. Okay. So if you add these points, you got the straight line. So this type of graph is called as uniform motion. So this is called as uniform motion. So dear students, already you know that what is uniform motion. Such a graph is called uniform motion. Why? Because every 10 seconds, 10 meter, equal intervals. So if an object travels equal distances in equal intervals of time, then the motion is said to be uniform motion. So this graph is now straight line, shows the uniform motion. Now the third graph is, so first of all, in 10 seconds, 10 meter. Okay, first it starts 10 seconds, 10 meter. Then even after the 10 second, next 10 second, it will be 15 meter. See, the 10 second, it will be 15 meter, 15 meter. Okay. Now, after 10, next 10. So like this, 10 second, 10 second, 15 meter. Then after next 10 second, 10 seconds, 10 meter, 10 seconds, 15 meter, 10 seconds, 18 meter. Okay, that take down 18 meter here. Okay, so like this. Now again after 10 seconds, it will be 25. So what you got? Now the graph you got like this curved line path. The graph is now you got curved path or curved line you got, curved path, or you got a curved line. Okay, such a graph, if you draw these points, curved line graph or curved path, okay, such a graph is said to be non-uniform motion. Non-uniform motion. So what do you mean by non-uniform motion? The object travels unequal distances. See, the distances are unequal in equal intervals of time. Such a graph is, or such a motion is said to be non-uniform motion. See, dear students, these are all the types of distance graph. But here, you have to remember, or you have to keep in the mind, on the x-axis, you have to take the time, and on y-axis, you have to take, see, on the y-axis, you have to take, okay, on the y-axis, you have to take distance, and x-axis, you have to take time. Okay, students, got the idea now? Dear students, now we discuss velocity time graph. In velocity time graph, on the y-axis you have to take velocity, meter per second. And here, on the x-axis you have to take time in second. Okay, this much you have to keep in the mind. Now see the first graph, in the distance time graph, in the first one, we got here parallel line. See, here you got the first distance graph we got here parallel, so this we got parallel. Okay, so line parallel to the x-axis. See, line parallel to the x-axis or time axis. In this graph, okay, you got the parallel line. What is the meaning of this? So time is moving. See, the time is constantly moving. But here, this is the velocity. See, this one is velocity. Velocity is in time 10 second, 30 meter per second, 20 or so 30 meter second, 30 or so 30 meter second only, 40 or so. So means velocity is constant. So such a graph here we are calling as uniform motion. See, uniform motion. In velocity time graph, the line parallel to the time axis or the x-axis, and such a graph is here uniform motion. Okay, students. Now, the second one. Second graph you see that equal velocity. See, we have taken here 10 seconds here, the object is moved 10, 10, okay, 10. Then after 20 seconds, 20 meter. Okay. And 30 seconds, 30 meter. So like this. Now 40 seconds, 40 meter. Now, if you join these lines, if you join these points, you got now straight line graph. See, straight line. Okay. Now, such a graph, see, for 10 seconds, 10 meter, next 10 seconds, 20 meter, join these points, you got the straight line graph. So, such a graph is said to be uniformly accelerated motion. Uniformly accelerated motion. Okay. Uniformly accelerated motion. What is accelerated? Change in velocity per unit time. So accelerated means change in velocity per unit time. See here, whenever you got such in velocity time graphs straight line, so that is nothing but uniformly accelerated. See, every equal time, in equal distances, equal time. So there is a uniformly accelerated motion. Okay. Now the third one is, you see, in the third one, you see the 10 minutes, here 10 seconds, okay, 8, only 8 meter. And next, in 20, 10 meter. Okay, so like this. Next 10, it will be 30, 12 meters. So in this one, okay, next 10 it will be of 18 meters. So now you got, if you are joining these, so you got a curved line. See, if you got this one, if you are joining this, you will get a curved lines. Okay, such a graph is now non-uniformly accelerated motion. See, such graph is now non-uniformly accelerated motion. Okay, non-uniformly accelerated non-uniformly accelerated motion. Okay, now you got three types here. First one, uniform motion, uniformly accelerated motion, and non-uniformly accelerated motion. So, dear students, now you will know that accelerated motion. Now, dear students, so we'll see the acceleration and retardation. See, suppose such a graph is given to you with the time velocity is increasing. With time, velocity is increasing. Such a graph is said to be accelerated. Such a motion is said to be accelerated motion. See, with the time, the velocity is increasing. Such a motion or such as this is a accelerated motion. Such it is called as accelerated motion. Okay, accelerated motion. Okay, here from A to B, accelerated motion. Now, time is increasing, velocity is constant. See, time increasing, here velocity is constant only. Velocity is constant. No movement. Such a this is called as uniform motion. Such one is called as uniform motion. Okay, with respect to the time. And next one is time increasing. See here, time increasing, velocity is decreasing. Time is increasing, but here velocity is decreasing. So such a with respect to the time, that is called as retardation. That is a retardation. R-E-T-A-R-D, retardation. That is a retardation. Okay. See in this graph, first one is acceleration because here velocity is increasing and here velocity is constant and velocity is decreasing. So like this way. Now by looking this graph already you can say that. See here you see this one is acceleration and here it is retardation. Okay, and here it is, what do you say? Uniform motion. So whenever such a graph comes, you can easily express your ideas. Okay, students. So remember both the graphs you have to practice distance time graph and as well as velocity time graph. Okay, thank you. Bye bye. Thank you for joining us.